Good morning everyone. My name is Lakshmi. So today we are going to teach about heat. Okay, so generally in our day-to-day life we are dealing with heat and temperature also. So but there is a difference between heat and temperature. So if you take heat, heat is a flow of energy. That means it is a form of energy which is flowing from hot body to cold body. So if you take heat, it is flowing from hot body to cold body. So whereas if you take temperature, it is the degree of hotness or coldness. In other terms, it can also be told it is a measure of thermal equilibrium. Okay, so now we are having the terms heat, temperature and thermal equilibrium. So what do you mean by thermal equilibrium? So if you take a thermal equilibrium, you have to take two bodies. So that should have different temperatures. So if they are having different temperatures and they are in coming contact with each other, then they will transfer energy. So both are having different temperatures means one is having high temperature, one is having low temperature. That means energy will be flowing from higher body to colder body. So this transfer of energy will be continued till both the bodies will get the same temperature. That means both the bodies should contain same degree of hotness or same degree of coldness. So all these three terms can be explained by taking one example. So just like one activity, we have to take two beakers. In one beaker, we have to fill hot water. In another beaker, we have to fill cold water. Now, take one thermometer and put it in hot water. So then you will observe the change in mercury level. So that means mercury level will be rising. So why? Because here mercury level is rising. So here if you take water, so that water is having high temperature, whereas thermometer is having low temperature. According to heat, that energy is flowing from hot body to cold body. If you take this experiment, so water is having highest temperature and thermometer is having lowest temperature. Obviously, the heat will be flowing from hot water to the thermometer. That means hot water is losing energy and thermometer is gaining energy. That gained in energy is represented in terms of mercury level rise. In the similar manner, if you take a cold water, so in cold water also we have to dip the thermometer again. If you dip the thermometer in cold water, then we observe this mercury level is decreasing when compared to this hot water experiment. So this means here cold water is having less temperature, whereas thermometer is having high temperature. So that means heat energy is transferring from thermometer to the cold water. So that means heat energy is losing by the thermometer, thereby mercury level is decreasing here. So here the energy transfer will be continuing, still both the thermometer and the hot water are getting the same temperature. So that means if the mercury level is rising, at that time both are getting into equilibrium with each other. Here also, so thermometer level is decreasing, that means both are getting into equal temperature. So that is only thermal equilibrium. So next one is units of heat and units of heat and units of temperature. So units of heat. So heat can be measured So first, anything can be measured in units. If you take water, so water will be measured in liters, mLs, etc. So like that, heat can also be measured, temperature can also be measured. So in terms of measuring, so we use units here. So units of heat. So in two ways we can give units, SI units and CGS units. If it is SI unit, joules is the units for heat, whereas CGS unit, it is a calories. Okay, so in the same way, units of temperature is also having SI units and CGS units. SI units of temperature is Kelvin. CGS units of temperature is degree Celsius. Degree Celsius generally we observe in thermometers. Okay, so next, calories. So if you take calories, 1 calorie is equal to 4.186 joules. That is a conversion of calories into joules. In the similar way, kelvins can be converted into degree Celsius. Degree Celsius can be converted into kelvins. So that relation is 0 degree centigrade is equal to 273 kelvins. So this kelvins, if the temperature scale is measured in terms of Kelvin, so then that temperature is known as absolute temperature. So that means temperature of Kelvin can be converted into temperature of degree Celsius. Further, we have to take 273 plus temperature of degree Celsius. So then degree Celsius can be converted into kelvins. Okay, so next, another terminology I am using. So that means kinetic energy. So we all know kinetic energy. What is kinetic energy? So that is if any body which is in motion will show the kinetic energy. That means moment of body. Okay, so now kinetic energy we are taking here. So there is a relationship between kinetic energy and temperature T. Kinetic energy and temperature T are having the relationship between each other. So what is that relationship? I am giving the statement kinetic energy is directly proportional to T. So you all know what is directly proportional to. That means if kinetic energy is increasing, temperature will also increases. So that is the relationship between kinetic energy and T. So this can also be proved by taking one small experiment. So now, in order to prove this, we have to take two vessels, fill it with again hot water, cold water. Now, sprinkle the water, sprinkle the food color. We all know food color. What is generally in our kitchen we use food color. Okay, so just sprinkle small amount of food color in hot water, small amount of food color in cold water. So then what happens? So this will be form a food grains. So food grains means small balls like, so that will be floating on the hot water and that also floating on the cold water. So that food grains movement we have to observe. So in hot water, so the food grain movement is more. In cold water, the food grain movement is less compared with the hot water. So that indicates that here in hot water, temperature is high. Here in cold water, temperature is less. So here movement is high, here movement is less. So that means kinetic movement is high in hot water, kinetic movement is less in cold water. So that means kinetic energy is directly proportional to the temperature. Now, the heat, temperature and thermal equilibrium and their units, all these things can be proved by taking one small experiment. So that is, in beaker, we have to take hot water. Half of the hot water only we have to take. So that means it will coming up to this level. Hot water. So above that hot water, we have to pour coconut oil. Okay, so we are pouring coconut oil and then this is closed with a cap and it will be having only two openings. Through one opening, we will put one thermometer in a coconut oil. Through another one, we will put another thermometer into a hot water. So now, if you observe the temperatures of this one, coconut oil and the hot water, so where here, so coconut oil is getting continuously increased. That means the reading of thermometer is continuously increasing here, and the reading of hot water thermometer is continuously decreasing. So why? Because this change, here temperature is increasing, here temperature is decreasing. Again the concept comes heat. So heat is transferring from hot body to cold body. Hot body here is hot water, coconut is normal water, coconut is normal oil. So now from hot body to cold body, so it is flowing. So temperature is increasing in coconut oil, temperature is decreasing in hot water. So that means here the kinetic energy increases in coconut oil, kinetic energy decreases in coconut oil. So there will be another small experiment, so that will give the nature of the absorption of the temperature. So that means the rate of the rise of temperature will be depending on the nature of the substance what we are taking. Here coconut oil is there, what hot water is there, both are having different natures. So depending upon the natures, what is absorbing more? So coconut oil is absorbing more heat, or this water is absorbing more heat. So that will be taken by one small experiment only. So again we have to take one big beaker. So in that we have to fill water. So then put 2 test tubes. You all know what is test tube. So in the test tubes, in one test tube we have to fill coconut oil, in another test tube we have to fill water. Here coconut oil, here water. So by using rubber corks, thermometer will be put it into this coconut oil and hot water and water. So now what we have to do? So this beaker should be heated. So this indicating heating. So if it is heated, so then first the water which is present in the vessel will get heated, and then through that it will be heated. Coconut oil will be heated and then water will be heated simultaneously. So that means for some particular time we have to heat both this coconut oil and this water. So for example 10 minutes I am heating. After 10 minutes, we have to check the readings of thermometers. So in coconut oil, the temperature is high. So whereas in water, the temperature is less. So why? Because means the rate of increase of temperature depends on the nature of the substance. We are using two different substances here. So nature, depending upon their nature only, they are observing the heat. So that will be proved by this experiment. So next one is specific heat. We know about heat. So what is specific heat? So this will be proved by, again we have to take small experiment only. So for that one again we have to take 2 beakers. So in one beaker we have to fill 250 ml of water, another beaker 1 liter of water. Now both should be heated, heating should be done. So for 10 minutes I am taking, so for your understanding only I am telling 10 minutes, otherwise it will be for some time they will say. So for 10 minutes we are heating both the waters. So then after 10 minutes if you observe the temperature of these two, 250 ml water is heated to, is showing the temperature of suppose 20 degrees centigrade. So then 1 liter water will show only 10 degrees centigrade. So why? Because this temperature difference. Here taking we are both the or waters only. Okay, so in the previous case we are taken coconut oil. So because of that reason they are showing different temperatures. But here in this case we are taking both or water only. So but we are observing the temperature change. So why? Because this temperature change. Here the only change is mass of the solutions is different. Here 250 ml we are taking, here 1 liter we are taking. So because of that change we are getting the temperature change also. So that means 250 ml water is getting heated fast than that of the 1 liter water. So that means, so amount of heat of absorption is higher for high mass of the substances. So that can be indicated by Q is directly proportional to T. So Q is heat of absorption and T is the temperature. So again another statement is also there. Q is directly proportional to delta T. So Q is directly proportional to delta T means, so Q is directly proportional to delta T. Delta T is a change in temperature. Okay, so change in temperature means if you are heating again 10 more minutes, that means altogether 20 minutes. So it is T1, it is T2. Change in temperature means T2 minus T1. So delta T is equal to T2 minus T1. So that is a delta change, so that is a change in temperature. If change in temperature is also increasing, so then heat of absorption will also increasing. Okay, so sorry, here I have written T, so that is M. So that means Q is directly proportional to mass of the body. So from these two statements you can write Q is directly proportional to M into delta T. So not we are writing, this is considered equation 1, this is equation 2. So then from the equation 1 and 2 we can write Q is directly proportional to M and delta T. So that is nothing but if the mass of the solution increases, then heat of absorption also increases. So change in temperature increases, heat of absorption will also increases. Okay, so next from this, so Q is equal to, if you have to write in equation form, so that should be equal to some constant. So M into S delta T. So here S is a constant we are using here. So S is a specific heat only. Specific heat. So from that equation we can write S is equal to, from this equation only, S is equal to Q by M into delta T. So Q by M into delta T. So that is the specific heat for the solution. So that means the definition for the specific heat is the amount of heat required for the rise of temperature of 1 gram of the solution by 1 unit. 1 gram of the solution by 1 unit, how much amount of heat is required? So that is known as specific heat. So from this specific heat, if you observe the equation of specific heat, S is equal to Q by M into delta T. Here S is directly proportional to Q and S is directly proportional to delta T. So that indicates that if the heat of absorption increases, then specific heat will also increases. So change in temperature increases, then specific heat will also increases. Okay, so next one, units of this specific heat. So what are the units for specific heat? Again, units. Units means you all know, so that is a measuring ones. Okay, so there are two units are there, SI units and CGS units. SI unit for specific heat is, that is equal to joules. So per kg Kelvin. K means Kelvin. Joules per kg Kelvin. So and CGS units is equal to calories per gram degree Celsius. Degree Celsius. So this is the units for SA and CGS units for specific heat. Now we have given the definition for specific heat. So that